Thanks. So this is the very first event in what we're calling the Fastly Security Speaker Series, and we're thrilled that you guys all showed up. And I just wanted to tell you why we're doing this, and it's probably the same reason that you guys are sitting here, is we just love this shit. So, fantastic. So we are thrilled to welcome two fantastic speakers, and right now I'm introducing our first speaker, Alex Pinto, who's the Chief Data Scientist of Nadell and the lead of ML-Sec project. And he spends all his time right now doing machine learning and developing data science techniques to support information security monitoring. We're thrilled to have him here today speaking about machine learning and its applications in security. So thank you very much.
Hello. Let me see if I can. Is this okay? All right. Hey, guys. Thank you so much for showing up. And I'm sorry for spoiling the first actual event from Fastly, because probably after seeing this presentation, you guys are all going to leave. So I apologize in advance. having you seen the presentation before from me. So anyway, I'll just try to do my best here. So like Windows said, this is a presentation about machine learning in security, right? And it's a lot about what works and about what doesn't work as well, right? Security is a very complicated it's a very complicated subject in a way, right? It's something that you have to do, you have to be in it for a while to really understand the nuances and really understand the things that should be relevant or not for you to be able to do your work properly. And data science and machine learning is pretty much the same. So when you put those two things together, you gotta you can't just conflate the FUD and the marketing speak so much, it gets absolutely impossible for you to understand what's going on. So this talk is a stab at trying to demystify it and trying to get you to feel like, okay, there's some aspects of this that could actually work, and there's some things that, you know what, maybe I shouldn't really be spending my time in this. So anyway, if either any of you are into the Twitters or something like that, please use the hashtag #SecureBecauseMath. Also tag Fastly because they love social media. Oh, hey, how's it going? I haven't seen you there. Yeah, so sorry, it's my friend there. He's my friend, I know him. So anyway, let me get started and see if this clicker works. Thanks for being here. So anyway, I really want to talk about, again, all this promise about the security analytics, right? And try to explain a little bit specifically for people who maybe are familiar with a little bit of machine learning and data science, why is security so different, right? Why should we claim, why should we be more careful while we're doing this onto security, right? And then I'm gonna go into a kind of a laundry list and trying to organize things as what does anomaly detection look like for security? What does supervised machine learning models looks like for security, right? To try to put a frame, so to speak, the way that we should understand these. And of course, some resources, if you guys want to take a stab at it, right? We really need more people researching this seriously, right? And trying different techniques and trying different things, right? And also, I have the checklist, so it really depends on the audience, right? Most of you here are builders, so I'm putting it as a developer checklist, as if you're building the security machine learning models in your companies, or you really want to do it for fun, what you should be thinking about on the back of your head as you're building the models, as you know, to really be able to make a difference. So anyway, let's talk about security analytics. So this is big data security analytics right now, right? So this is the mythical animal, right? We're being sold, right? And this is really the solution to all your different problems, right? There's absolutely nothing that could go wrong once you start working with security analytics, because, I mean, like every single other security solution that we've had over the years, right? It's going to solve all the problems that all the other solutions didn't solve for us so far. So anyway, it's good. We can all go home now. We don't really have to rest. So the thing is that the way that this heavy-handed marketing works, right, it becomes really hard for you to differentiate what's going on, right? So you get the hyperdimensional security analytics. I guess it has more than 3 dimensions, right? The 3rd generation artificial intelligence is the one that I really like. It's the third iteration of the Matrix now, right? with Neo has shown up like 2 times already, right? And of course, the title, Secure Because Math, and then actually this company, which I shall not name, after I started making Secure Because Math popular, they changed it to Math is Bigger Than Malware. And I don't really like to pick on them at all because they're actually doing supervised models, which I think are much, much more solid than trying to do anomaly detection. But come on, man, you can't do stuff like this in marketing and don't have me pick on you. It's like you're just joking. But anyway, the problem is, again, and this is a much bigger problem than machine learning, much bigger problem than general marketing for these things, right? Security marketing is very heavy-handed, right? And so you have the FUD of trying to, oh my God, you're gonna get breached, and now you're adding the FUD of, we have all this math, and you don't have to worry about it. We have these PhDs on it, don't worry. So it just gets too bad. I mean, I really cannot really hold my tongue against those things, right? And I've been criticized about being so vocal about this because maybe it's a communication issue, right? Maybe the marketing people, they're just trying to translate the best they can, whatever input the technical folks are going to them. But there has to be some temperance, right? At the end of the day, this makes us all worse off because we're not really knowing how to select, how to understand, or how to address the solutions, right? So why do I care, right? Why am I hating on machine learning? Because we all know that machine learning is the thing. So the next startups for the next 2 or 3 years are going to be X, but with AI. We all know that, right? A bunch of you in the audience are probably planning what you're going to pitch, right, for the VC meeting that you have in a couple of weeks. So it's definitely going to be X with AI. So why am I hating on it, right? I mean, we're used to having machine learning in general IT, and actually artificial intelligence, quote unquote, and those things are really a part of the experience that we have right now, right? But then ad networks use it very extensively, and product recommendation, all those things. But honestly, I mean, how many times have you actually called Facebook support to say, okay, I just got a very bad ad right now, you know? I actually wasted 1 hour looking at this ad here that I just got, right? It doesn't matter. The outcome for a false positive, the actual cost of a false positive or a false negative when they're serving ads for you or when they're doing product recommendation, for them, they will show you 10 products on Amazon or whatever. You only have to pick one. You only have to buy one of them for that specific campaign to be absolutely incredibly successful. Doesn't matter if the other 9 are just like repeat issues of, I don't know, I was going to do a funny example, but I can't really think anything clear now. But it's bad stuff, and then the good stuff you just bought, it doesn't matter, right? It doesn't really matter, but in security, it matters a lot, right? Not only the false positive makes it much more expensive for the teams to handle those things, right? The false negatives could be disastrous, right? If you're relying on one of those things to actually tell you what's wrong and what's right, and a breach or an exfiltration goes wrong, it could have real lasting damage, right? So this is an interesting story actually, because when I first wrote this presentation, I first started putting together the ideas for this presentation. I created a structure like, these are the things I want to talk about. And I presented it at Black Hat. And then a month or so later, someone introduced me to this paper, which is Outside the Closed World. And it's from Robin Summon and Vern Paxson. So for you who don't know, Vern Paxson is a professor at Berkeley, and he's the one who wrote Bro, right? I mean, he's not doing it right now, but he's the one who started it. He's the one who created it. And he has a thing or two to talk about network detection, and he has a thing or two to talk about also statistical models on this. A lot of his research right now is around this. And this paper, and anyway, what was interesting for me is that the ideas that I put down on paper to try to structure this presentation were very similar to what this paper said, and I hadn't read the paper yet, right? I mean, of course, he did it 4 years before because he's a genius and a professor, but it's fine. I was happy because there was someone who agreed with me, for sure, right? I mean, yeah, it's got to start somewhere, right? And there's a lot about what he talked about, how hard it is for you to validate a false positive or negative. The fact that it's there's very, very scarce ground truth, right? And a lot of different things that I'm going to touch on this presentation, right, that make it super hard to apply the traditional quote-unquote techniques that we have developed over these years around machine learning to try to solve an actual security problem, right? And if any of you are interested in, not Vitaly, Vitaly has memorized this paper already, but if any of you are interested in pursuing machine learning for security, this is an absolute must-read, right? Because it gives you the frame of reference. Again, it's an old paper, right? Old, 5 years, 6 years. But, and some of these things, I mean, there are ways that techniques that people have developed to help through it, but it's a very good way to frame your mind onto how I should be looking at this problem, right? And one of the points that they touch is around the difficulty of evaluation, right? Now that you have built a system, how do you know if it's good or not, right? And it ties into the fact that as security people, we're naturally very secretive, right? We're not going to be sharing our data willy-nilly, right? And just telling everyone, yeah, this was the guy who breached me. I actually have a whole other series of talks about threat information sharing and the incentives around that and why people don't do it and should be doing it more. But that's not really the point. The fact is that public data sets and things that people would do for research in this area are very, very scarce, right? And it's interesting because way back when DARPA, and this was before the 2000s, right? This was 1999. I mean, nobody here is like, okay, no, I guess we're not there yet. There's probably going to be a moment when I'm like, I'm going to be doing this talk and somebody, I wasn't even born yet, and I'm like, yeah, that's how bad we are. So on 99, we already had Bro and we already had Snort, right? And so DARPA helped fund these things actually as research. More Bro than Snort, to be fair, but and then they said, you know what, we're pretty good on this signature kind of thing. Maybe we should invest some money and ask people to research behavioral stuff and try to figure out anomaly detection or try to do some more statistical analysis out of detection of malicious traffic, right? And then there was the famous KDD99 data set, right? Which actually, if you look at it, it's hilarious because it's like Solaris audit logs, right, from that time, right? It's something that nobody really has right now. I mean, hopefully, right? If they still have Solaris boxes running, I'll feel sorry for anyone who does. But but anyway, my point is that when it was released, it was super successful, right? There are over maybe 7,000 now citations on Google Scholar about people who've used the data set, and it helped them kickstart their research, right? What gets me mad is that if you go to Google Scholar now and you search how many people are using it now, there's probably like 200 papers who are still using KDD99 as their evaluation metrics for their models. And I'm like, we may have invented some new ways to attack people, right? There may be some other things you should be considering, right? And again, it's not really their fault, right? Especially if you're publishing something, right? The data set has to be public, right? There's several other public data sets right now from vast challenges and things like that. But it seems like people really, really like the KDD99. It's almost like, I mean, you're in med school, right? And the only thing you have to do for anatomy class is this painting of Rembrandt, right? That's it. And someone will go, yeah, maybe we should cut someone up again. No. This picture will tell you everything you need to know. That's what you have to take into consideration when studying anatomy. So it becomes kind of futile, right? And I personally have a suspicion that a lot of the people who maybe started those startups or startups who started going into this anomaly detection thing, they got a couple of PhDs who were doing extensive research on KDD99 and they thought they were doing super well, right? But it didn't really have the opportunity to test it on real life data, right? And then when they actually moved into the real world, right? And that's the point of that whole paper, the outside the closed world, right? They thought, well, it's not that easy, right? And even at the time, this is a paper from 2000, right? People were saying, you know what? I don't think this KD99 experiment was a good idea because people were just trying to overfit the model and just get the 1/10% better than the other guy. I mean, this is not really taking us any further, right? And we still see things like this. I mean, not just on security, right? I mean, people go crazy on ImageNet all the time with the deep learning and all those things, but I mean, are we really pushing the industry forward in a way? My bet is no. So anyway, there is a significant lack of data, right, to actually do the research, right? And way back when I started talking about machine learning, I would be doing these presentations and talking to them about, hey, why don't you let me have your data, right? So then I can play around and learn a little bit, right? And it was really what enabled me to develop the things that I did and to learn things that work and doesn't work in security, right? And that's definitely a message I would give to anyone who's trying to do this work. It's like, you need to have real life data, at least from your own environment or something like that. So anyway, let's talk about anomaly detection because anomaly detection actually makes some good examples of challenges that we have on the security field, right? And the thing about anomaly detection, right, and anyone who has tried doing it would be able to put it in those terms. It's very good at simple stuff, right? The way we understand anomaly detection, the way that we try to frame it, is that we actually have a very well-controlled environment, a very well-controlled process that you have, right? And then you can ideally understand if you're deviating from these specific known markers or known means that you have, right? I'm not going to go into central limit theorem or anything like that. It doesn't really have to be that normal distribution, but at least if you know that you're in a factory and you're building bolts and you know that the bolt has to be at this size, right? You know if it's a little bit bigger, a little bit smaller, and then you can try to look for that, right? And there's also a lot of history in anomaly detection as the seed for fraud detection, right? So, I mean, something I see all the time is, again, people arguing for general anomaly detection in security as in, well, but it works for fraud. Well, it's not the same problem, right? The number of dimensions and the number of things that you're measuring in fraud is usually much, much smaller, right? In a way, you only have kind of one dimension, at least when you look at it in very simple terms, as in how much people are spending or putting into their environment, right? So it all started from that. It's, of course, much more complicated than that when you're talking about financial fraud, but this is where it all got started, and this is where it all got confused and conflated, right? So again, DevOps, right? You know how much CPU your machines should be going for, right? You can measure against that, right? You understand how your I mean, assuming you're not doing like 100 different very fluctuating code bases every single day, but you know at least what to expect. So it helps a lot in monitoring. And those are all different dashboards that are looking at one specific dimension, right? So if you can tell that this specific dimension is overshooting or underperforming than what you would want to, right? It just gets, it gets very clear to you. It gives you a clear message that maybe you should be looking at something in that direction. So people got into that, right? And said, well, maybe I can do this for security. Maybe this is the thing that's going to work for us, right? And we had, back in the 90s and maybe early aughts, we had a lot of companies who were claiming to do network or NetFlow behavioral analysis, right? And they all kind of graduated now to the user behavioral analysis, which they will never tell you that, but it's actually the same thing, just on a different abstraction level, right? And it baffles me to no end the fact that no one realizes it's actually the same thing in a different abstraction level, and if it didn't work back then, it's probably not going to work now. But hey, right? I think we should give them a go, right? Maybe this is the time that we get this anomaly detection thing right. So it is the new hotness. You've probably, if you are in security at all, and if you're being bombarded by vendors, I mean, it's RSA week next week, right? So yeah, you've probably heard all of those behavioral analytics companies. You know them by heart. So what is the problem, right? The data is too diverse, right? If you would try to do some sort of general anomaly detection, right? Oh, the system will figure itself out, right? The thing about anomaly detection is it's nothing more than you're trying to measure a distance to something, right? You have think about clustering, right? It's a usual way to understand unsupervised models. You're trying to find things that are similar. So then if something is like way out there, that's probably bad. But how do you know if things are close to each other? You have to find out some sort of distance, right? And what happens is the more dimensions that you add, if you're looking at, several different ways of looking at the data, right? Each one of those dimensions, and I'm definitely not going to go into the math here, but the more dimensions you have, the more the distances look the same, right? And I had a slide which had a beautiful curve, it's just about, an easy way to visualize this is that think about you have a square and you have a circle inside a square, right? And then you have the part of the circle that's outside, the area of the square outside the circle, right? And think about, you're trying to find the distance of whatever size the square is, half the size of the square actually, from the center of the circle to the top. So it's a circle inside a square, and you see the area. If you go to the cube and the sphere, oh, wait, there's a lot more volume outside the cube and the sphere than you had area on the square and the circle. And it only gets worse. The more and more dimensions that you add, the more insignificant becomes the actual hyper volume, whatever you want to call it, of the sphere in relation to the whatever hypercube you have. The distances, they quickly become meaningless the more and more dimensions that you add. So if you think about a network with 1,000 nodes, right, and you're trying to figure out how all the machines talk to each other on network ports, and I'm being very simple net flowish here stuff, right? You'd have 500 billion possible dimensions. Think about if machine A is sending a packet to machine B, that's a 1. If it's sending back, it's a -1. Each one of these is a kind of dimension that you're trying to measure if whatever they're negotiating or talking about is normal or not. It can get very, very complicated very, very fast, right? So that doesn't work, right? And no matter how much people tell you that they figured this out, there's a lot of different ways for you to measure distances. There's a lot of non-Euclidean stuff that I can't even pretend that I understand and try to make some stuff up for you. It's like, it's way, way out there, right? But, and I did it like organizing the space in sub-manifolds to make me sound smarter, right? But I actually have no idea what that means. And so the point is, right, actually trying to do general anomaly detection on those kinds of scales, it's completely pointless. And this is not, oh, Alex doesn't like the security companies that does this. Oh, Alex doesn't like anomaly detection. No, this is math. This is the fundamental thing. If someone came to you and said they were doing this to the general thing, they're stupid because they would be making a killing, curing cancer, right? And doing all sorts of much more interesting things, which you can reduce to exactly this problem, right? Figuring out genetic variations in population, what are more likely to generate diseases or not, right? So I don't think it's security that's going to crack this problem. I think it's probably going to be someone else, right? Maybe we're going to be able to use it when it happens, but that's not how it works, right? And so what people will do, no matter what they say, is that if they are using anomaly detection, they'll have teeny tiny models they're running on very, very small dimensionalities. They will tell you stuff like, oh, you know what? You actually had a bunch of failed logins this time, right? And that's their anomaly detection engine. But then they have another one which is, oh, this machine is downloading a lot of files in the network, and that's your anomaly detection engine, right? That's the kind of thing that you're going to see in the wild, because that's actually what's possible to be done in any sort of meaningful way with what the math looks like, right? And anyway, That's as far as the custom dimensionality is concerned. There's no general anomaly detection, right? Especially at these dimensionalities, right? So, second reason why I don't really like unsupervised models is because of the normality poisoning attacks, right? Which is, well, if you're looking for an anomaly, it really becomes about what's normal, right? So then you're trying to differentiate what's normal against the anomaly, right? And I have this thing that I really like. It's kind of my Maslow pyramid of machine learning, which is, given that you have a model, that you're trying to build a model, the actual time you spend on ground truth, right? The actual time you spend on having and I'll get into what ground truth and features mean, right? I'm going to be talking about that in supervised models, but the idea of the ground truth is that, oh, this is A and this is B, right? And then I'm going to try to tell them apart with the model. So actually knowing what you're looking for, actually knowing what the classes are, it's very good. It helps a lot in you building a functional model, because if you have mix-up, if you're not sure what things are, doesn't matter how you train the model is going to mess up because you told it wrong the first time, so it's never going to get it right, right? And then you go up to feature selection, which is how you describe those things, right? And that's a little bit less important than ground truth, right? You can have a great feature selection process, but then you have messed up ground truth, still not going to help you. And finally, the algorithm. Nobody cares about the algorithm, right? Unless you're doing like normal linear regression, which is like, I mean, it works very well for like teaching in a class, but it's not going to improve your results a lot, right? So I don't like machine learning because I don't like anomaly detection because of this. There's no ground truth, right? So there's a lot that you lose in putting those models together and putting the understanding of what you'd have to do, right? It's kind of the lazy person's exit on trying to build a model and trying to deliver some sort of result, right? And I love this example about Waze, right? And because it ties very well with the idea of poisoning, right? The idea that you don't have the truth, so someone can probably tamper with the data that you have. So there's this story about the cops putting the air in the wrong place, right? So then people are speeding and then they get caught. I have another story which I actually find it's interesting. It's like, so back. I used to live in São Paulo, and Waze got really popular in Brazil. And Brazil has this thing about apps. It's like, for some reason, they'll get very popular all of a sudden because everybody's using the same thing. So, I mean, people are very social there. They try to do the same thing as their neighbor. So anyway, people would, oh, God, it's 5 p.m., I'm going to leave the office. So they would get into Waze and then just put a bunch of accidents around their office, right? So then the traffic would all go out, right? And so they would be able to just drive off, right? And it's funny. There was actually I think there was something on the media about Waze. People telling, oh, people were doing this on Waze. No, they're not. Of course we catch them. Yeah, sure you do, right? What you're gonna say on the media thing? But this is the kind of thing that can happen if you don't have control. And this is a huge problem on adversarial machine learning. I'm not even gonna go into there, right? And anything, again, if you don't have control of the log, this goes much beyond machine learning. If you don't have control of your telemetry, if you don't have control of your logs, people will potentially mess up with you on an adversarial environment. But it's a little bit worse in anomaly detection because people can actually, it's like, I'm not sure if is this probably an expression in English as well, the boil the frog, right? You put the frog in the pan, and you're just boiling the frog, right? There was actually a talk this last year. I don't remember whom. Someone was clearly presenting a framework on how to do this. I didn't really watch it, but it should be interesting to check it out. I mean, people are talking about this as a potential solution to resolving. I'm probably terrible for time. How are we doing? Okay, I'm good. I think I can do this. I'm terrible with timekeeping, by the way, right? I just go on and on. So another reason why I apologize for being like, yeah, thank you so much. So this is one of my favorites. It's called the semantic, it's very politely said as semantic gap on the paper. I like to call it Hanlon's razor, which is never attribute to malice what can be adequately explained by stupidity. So let's say you're looking at an anomaly. How do you know the anomaly is malicious, right? And this is the biggest problem in any sort of deployment that you would try to do of something on a tool like that. And I remember back at the day, maybe on the 2000s, you guys remember ISS? You probably do, right? So ISS actually released an anomaly detection product in 2002, 4. I don't even remember anymore. The years have all compressed by now. And at the time, I was working at the biggest ISS integrator in Latin America, right? And we did everything, all the products. It was success after success after success. We knew everything inside out, all the IPSs and IDSs. We never could get one of those to work, right? And maybe it could have been us, right? But one of the things that I would tell people when I was getting in to try it out is that, okay, these things, they shouldn't be going to your security team, right? You probably have 1, 2 people here. These are anomalies. This probably should be going to your, I mean, I wasn't even allowed to say ops at the time. Nobody said that. The general IT people. So then they can look at it as an IT anomaly of some sort, right? And that's potentially helpful. And then we're going back to the DevOps example I was going to again. I was doing before. And then if they are not able to find out the reason for that, maybe they should refer it back to you. It's more likely to be like they just hired a junior developer that decided to upload some Node.js code to the production server because it was closer to the metal, right? Than someone actually maliciously trying to do something for you, right? So, I mean, they don't mean anything. They're devoid of meaning, and that's hard, right? If you're not looking for something specific to detect, right, anything potentially looks like a problem. So I was talking a little bit about the user behavior, right? And the way that I think that it can potentially be misleading, right? And I'm not saying they are completely devoid of value, right? It's just that sometimes their value is misstated, right? And this is what we need to be careful about, right? So first of all, it's the behavioral analytics people are usually try to conflate whatever they're doing with the fraud detection, product security kind of thing. So when you're building product security for your product, right, it's usually, there's a very narrow scope of things you're looking for, and you're very easily able to define what's good and what's bad, and then create not an anomaly detection function, but some supervised model that helps you find out things that already have been vetted by your fraud team or whatever your abuse team, right? So you actually have a healthy feedback with the people who are using the system, right? In order to provide you, again, in the parameters of whatever your product does, if something should be reinforced or something should be, oh, this was actually a false positive, we should let it through, right? When people talk about fraud detection, when people talk about product security, those are supervised models. Of course, these are supervised models who, as part of their feature set, they will take into consideration behavioral characteristics of the users or of the system. But you gotta be very careful about the difference between the terminologies and the objectives, right? And like I said, it works very well if you're looking for tiny things, right? So honestly, if they would come to people and just say, you know all those things you could do with ArcSight 10 years ago, right? All those things you could do at your SIM, which are like, oh, I want to know if someone is logging in too much and failing their passwords, or I want to know, if someone is sending too much files. You don't have to write the rules. The rules are already written. I think it would sell like hotcakes already, right? And people, oh, okay, yeah, I don't want to mess with ArcSight anymore. That's terrible, right? And they would buy it, and they would use it, and they would be happy, right? But that's all they do, right? That's all that they are able to do with the current technology that we have. If that's what you're looking for, that's what you want, perfect, right? But let's not misstate the problem. Let's not try to oversell and then ruin it for everyone else. This is the kind of thing that gets us through AI winters, right? Everybody gets really discredited that, oh, okay, this is bullshit, this doesn't really work, or this is not what I was looking for. And then a whole class of people who are trying to build machine learning into security problems, they just fall on the wayside, and we get the next I don't know, whatever. I can even manage to do any more predictions on where we're going for security as well. I just hope for the best most of the time. So anyway, that was it. And this is just like some advice, right? Don't use unsupervised machine learning algorithms in production. Anyone here not in security who is a pure data scientist will probably agree with me, right? It's great for exploratory, great for learning about your model, great for learning what you should build, but please don't put it on prod. That's just lazy, right? So anyway, this is the thing that I get the most. What? People use unsupervised machine learning security? They're crazy. Anyway, I don't make up the rules. I just try to do what I can. Anyway, let's talk about supervised. It's a much happier subject, right? And I'm just going to try to give a very interesting example, a simple example that will help illustrate the challenges that we have with supervised machine learning. So let's say we were hired to deliver an image recognition software that tried to tell apart dogs and cats, right? Google has done it many times over, right? It's our turn. We can do it. We have the technology, right? However, if all the pictures we have for cats are for Grumpy Cat, right? And all the pictures of dogs we have are for Doge, right? We may face some challenges, right? Specifically for Grumpy Cat, you probably would never classify this happy fella as a cat, right? I mean, cats are grumpy, right? You've either figured out, I mean, your model, the way you have built stuff, either figured out that cats are grumpy because grumpy is a part of the feature set, right? It's the way you describe the picture. Oh, this picture totally looks grumpy, so all the cats I have are grumpy. So if a cat is happy, you're not going to get it, right? So the same thing for Doge, right? If all the dogs that you have examples of are super majestic and thoughtful, right, and very brainy, right, you're not going to get this guy. I mean, poor Tuna. Tuna's a great, you should follow Tuna on Instagram, by the way. I don't get a dime for that, but he's super funny. So this is the main challenge, right? And this is the reason why people, especially people who again, are not used to security and they go into machine learning for security. Oh my God, there is no ground truth, or ground truth is super hard to come by, so I totally have to do an unsupervised model now. And they don't even try a little bit harder to figure out what were the sources that they would be able to use, right? These are real problems in supervised, right? The ground truth problem, right? Again, ties back to people not sharing, we not having public data sets, right? And at least my take is that, at least for now, right, after we have painstakingly uncoupled all the functionalities of antivirus because we thought we could do a better job than antivirus, and now everything is sold piecemeal for us, right? So then we can spend all the money all over again. We have actually good sources of malicious information. We know we can get feeds that tell us that IP addresses are bad, that specific binaries are bad, right? There are actual sources of ground truth that have been human vetted to do this work. Non-malicious is still a little bit harder. I have this talk from, this was ShmooCon, I don't know, a couple of years ago, from Irina. Irina was in Checkpoint at the time, and I'm not really sure if she's still there. But it was an interesting take on their process to figuring out whitelist data, or data that they should, I mean, everyone is experimenting with those kinds of models, and what the process they put together to actually figure out whitelist data. I mean, if you just go for Alexa, you're going to have a bad time, right? You can't go very deep into Alexa because there's a reason why things are popular. Sometimes it's because it's serving a lot of malicious traffic. So the other challenge that people talk about a lot is the timeliness, right? The thing about security, the thing about something as fluid as security is that, and then there's this, oh, it's human adversaries, we're never going to be able to automate it with a machine. This is one of my favorite arguments to destroy. But the thing is that people do evolve, right? When you present a solution, when you present a control, the attackers will evolve, the ecosystem will evolve. So you have to be continuously retraining the models on a supervised to account for this adjustment, right? This is a part of the process, right? But it's not like it's super hard to train a model again, right? Especially with all the open source software we have right now that helps you marshal this massive amounts of data and use them for machine learning or data processing or whatever we want, right? The thing about what I'm much more happy about classification models, because you actually have to think about what you're doing, right? You actually have to figure out, this is data set A, this is data set B, this is good, this is bad, or this is there's some sort of behavior or some sort of a feature that I want, something that I want to detect against the things that I don't want, right? So if something comes up as positive, you can actually tell, well, this was a part of a model, I was looking for this, so it's probably positive for this, or at least within the levels of confidence of the model that I have built, right? So right now, there's two big fields here, right? And again, it's just like security for everything. There are people who are focused on endpoint and there are people who are focused on network, right? Are we looking at, okay, are we looking at the way that the processes execute on our machines, or are we looking at the way that they talk to the outside world, right? The malware data is super interesting, right? And there's a lot of published information on this, right? There's a lot of papers, and there's a lot of very interesting results that people have got. And there's a lot more success in clustering malware. So you've probably heard this word 1,000 times, especially when people do reports about specific families. So if you know that something is bad, right now it's super easy to tell you what it is without you even looking at it, without you actually having to reverse it. You can pretty easily tell, and sometimes you don't even need machine learning. There's a lot of like creative hashing going on to actually find the similarities of different families. People got very, very good at that. We're still very, 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 very bad. I think it's unfair. But we still have a long work to do in order to be able to actually detect if a specific thing is malicious against all the other things, right? And the thing that I tell people is that AV companies actually had the state of the art of this for a long time, right? They definitely had the most data. They definitely had the most time to tinker with it, right? But somewhere along the way, the people who were doing the research, they got discouraged, and then they left, and then they started their own companies. So every single company that you see who are trying to do something in this area, right, they are people who had left the research teams of AV companies, and maybe they got fed, maybe it's bureaucracy, I'm not sure, right? But we're still continuing the same research, right? It's still the old AV research, right? But I'm actually very positive about this. I think we're doing strides to do this, right? I was actually super happy when I saw that a company who is actually working on this kind of layer, no, I'm trying to do things, use as much machine learning as I can. They're trying to fight in an even term with AV companies. And I think that's super interesting. That's like popcorn.gif for me, because I'm super curious to see if they're gonna be able to manage it, right? I think there's promise in the technology, right? I still think we have ways to go, but it's definitely interesting, right, to see that going. So, but still, you have to be careful. Anything like this, especially if you're trying to look at the papers, there's still a lot of bad papers, right? So, I mean, you have to be aware of how people are structuring their experiments, how people are training the algorithms, because you know what? If you're trying to compare known malware, if you're trying to train a model of known malware against, you know what, the files that Windows has when you install Windows, it's like Windows XP 1, Windows XP Service Pack 1, right? You're actually building a classifier for Windows XP SP1 files. You're not actually building a classifier to find malware. So it's super tricky, right? Again, if you're not sourcing your ground truth correctly, right, there's all sorts of different pitfalls that you can have. So network-based data, there's a lot of interesting techniques, right? And the idea of IP reputation starting out is really the first step. There's a lot of interesting stuff about DGA. I mean, this is like baby's first machine learning model for network is let's build a DGA classifier. There's 1,000 examples you can find on the internet as well. It is a super fun example, right? And it's something that's relatively simple to do, especially because it's very easy to find DGA generators in the internet as well. Dambala has, there's the talk from Dambala. This is also from Shmukon, has some very interesting ideas and way to do it. They don't tell too much, but it's super interesting to see. And there's another interesting technique about actually trying to run malware, so getting the PCAPs of malware communicating out and using that to train a supervised machine learning model, right? It's a little bit harder, but I think it's interesting. The research they're doing, they're trying to do it very straight and trying to see what comes out of it. What I have been doing, right, I have been on this specific space as far as supervised machine learning is concerned, right? And the twist I've put on it is really focusing on the threat intelligence data, right? And using the threat intelligence data, again, you can find it. It's not hard to come across this sort of information. And then trying to mimic the way that the analysts would use the data and pivot on this data using passive DNS and WHOIS, all those different things, to try to then come to the same conclusions the analyst would have if they, I just saw this domain here going through the network. What do I know about relationships with those other things? Do I have reason to believe that this is malicious or non-malicious? Again, it's a supervised model like any other. This is my take. This is the nook and cranny that my research took me into. I'm super happy about it, but this is not by any means the only viable way for us to work with machine learning in security. I'm specifically very curious and very positive about people doing the work on the supervised area and trying to figure out clever ways to describe the data, right, and clever ways to present the data and come to, and honestly, it's interesting about security is that whatever the classifier is telling you, whatever rate it's getting, it doesn't really mean a lot. It's like, how do you, as you interact with the people you're working with and try to understand if this is valuable for them, that's where that's where it gets really interesting. That's where you really should be aiming as a data scientist. Is this useful as opposed to, I got a 99% accuracy rate or something like that. And that's super hard. So very quickly, I mean, don't bother with deep learning. It's just premature optimization. I mean, talking about the pyramid, right? If you don't have good data, if you don't have good feature sets, it's not going to make any difference for you. It's not going to save you, right? And specifically, I think neural networks are a bad fit for security data because there's a lot of missing values. It's very categorical, right? I mean, it really depends on the way that you're trying to build. I mean, there's all sorts of different takes. I actually researched an interesting counterexample of people trying to figure out if a malware is this or that. It's kind of a classification, a one versus many classification, where they were trying to use NLP. So this is natural language processing. So using the same kind of technique that, I don't know, Google would use to figure out what language you're typing on, right? To try to figure out, let's look at the way this execution flows, right? This actually looks more like this guy or that other guy. And NLP is something that you can apply deep learning to, so that's probably an interesting result we could see out of those kind of things. I'm not super positive. Takes a long time to train, right? Unless you get unless you repurpose your Bitcoin farm, right, to actually do this now. So anyway, timeliness is a thing. But anyway, anytime someone comes to you and tells you we're using deep learning, it's like when someone comes to you and say we're using Python. It's the same kind of thing. It's just the name of the programming language they're using, right? Also correlated to that, if someone tells you we're solving this with machine learning, just mentally replace we're solving this with programming, and suddenly it sounds much less exciting. But it's the same thing. It's the same thing. So anyway, I think we can do this, right? And we just need to be, again, we need to be able to understand where people, and this is where I come from, right? There are things, things have been tried for 20 years and doesn't work. Don't spend your time on those. Right? Let's try to figure out where the research is going now and maybe try to contribute to that if you're interested, if this is something that interests you. I think it's super exciting. This is what I'm doing with my life right now. I'm having a lot of fun. So I have some sources of it. I'm pretty sure we're going to have this slide deck up somewhere, so you don't need to bother about this. Some sources of data here, right? And Mike Sconzo specifically got a very nice repository. He called it sec repo. There's all sorts of different security-like data that you can use to play around, right? Maltrieve can pull malware samples from threat intelligence lists. Combine was a project I was working on a year or so ago, which would be able to pull threat intelligence feeds from open sources, right? Here's some good ideas for research, for feature generation, right? Again, Sconzo is everywhere. He's a great guy. He's at Bit9, actually Carbon Black now. And I love his work. He's been doing a lot of work in analyzing security data and using a lot of stuff in Python. I'm more of an R guy myself, so he has a lot of good stuff in Python for people who are interested in that. And but anyway, I just want to finish this talk. I just want to think about when you're thinking about security in a machine learning solution, right? There's some questions that you need to ask yourself if you're trying to evaluate or trying to understand if this is going to be helpful. I guess the first of all is, what are you trying to achieve, right? There's a lot of things that, actually, I can just do this very deterministically in some other way. There was no reason why I needed to do some sort of statistical thing here to solve this problem. Some problems are impossible to solve like that. They're too big a scale, right? And you definitely need to be able to treat this in some sort of machine learning way. But the first thing you need to ask yourself, okay, is there a simpler way for us to do this? Because most of the time there is, right? This is the little secret. And this, honestly, I'm told that this is one of the reasons why most companies, they're trying to do machine learning security, they struggle because they try to do everything with machine learning and they don't really understand, what, some things are actually easier the other way and you'd have better results. Think about where the ground truth is coming from. Think about protecting the ground truth, right? And also, more importantly, don't hide your head in the sand, right? There are going to be false positives and false negatives. This is a natural part of any sort of modeling, any sort of thing, right? So how do you handle this on your model? How do you handle this on your system? How do you handle this on your model to make sure that the model can somehow gather feedback from whatever is interacting with it to actually get better and better? So anyway, that was pretty much all I've got. And thank you all. I'm not sure if we have time for questions. Yes, we do. Yay.
So I think we have a little time for questions, and we have a mic. So if you want to ask a question, raise your hand, and then be recorded for our internet viewers.
You are on the internet, guys.
You in the audience aren't actually on the internet. You on the podium are.
Come on, just one. You know what's terrible? Yes, we have a couple. It's terrible when no one has questions. It actually means, it either means you did very well or you did very poorly. It's very hard to tell.
Hey, do you feel that like a walled garden makes machine learning more practical when you kind of have, I guess, less dimensions going on, or things are more in a controlled environment? Because it seems like a good example I'd give you is like the App Store with the iPhone or with Apple. It doesn't seem like they have a malware problem at all. I mean, maybe once in a while something gets through, but it seems like that problem is pretty much solved. So is like a walled garden the solution to the problem?
That's interesting, because that's an interesting question. Thank you. Because there is a whole belief system in security around, you know what, we're spending too much time trying to figure out what's bad, when actually we should just be enumerating what's good and only let people do whatever is good, right? So there's several products. I mean, people generally call them whitelisting products, which is like, okay, what's running on this machine right now? Oh, these are the binaries, these are the things that are there. And then you kind of create a snapshot, and then whatever else runs into the machine that wasn't on this initial snapshot, it doesn't run or anything like that. That's a great idea, right? What happens is in actual practical implementations, it becomes very challenging to maintain those things, right? When you're talking about something that's a purpose-built device, like an iPad or an iPhone, it becomes a little bit easier because there's a lot more control about the different kinds of tools and things that people are going to use. When you're talking about, oh, I have a computer for my developer, it can become very messy very fast. So this is the main reason why people don't do that, or at least when they do that, it sometimes is in a very reduced scope. Definitely it would make life much easier, right? But I mean, if I could fly, my life would be much easier as well. But that, unfortunately, that's not the way the world works. It was an excellent question, though. It was an excellent question.
So I think the question was around like when you generate a data set, like typically you would use tools like which are like signature based. So if I try to do a project myself, unless I have like a paid feed which is like human vetted, I mean how would I basically because most of my data would be coming from like signature based tools that this is bad and this is good.
I would say okay. I would definitely say that you definitely don't need to spend money, right? Especially if you're starting out, right? And specifically trying to get this data, right? There's a lot that's available in signature-based tools. There's a lot of open feeds or things that people share in blog posts and public. I mean, just the other day there was another APT report, right? Which like with a couple of pages of domain names and IP addresses that were all bad in a specific point in time. There is a lot of data. I mean, you have to be diligent in searching for it, right? Most of the, I'm not telling everyone is like this. I mean, there's a lot of people doing some very hard work and very good work, but sometimes, some of these guys you pay for, they're just like doing this work for you, like getting all those things and curating it and presenting it to you. There's a lot that you can find on your own. I have a whole other talk about figuring out sources of threat intelligence that you can find in the open and then comparing them and doing interesting things in them, right? That you can definitely use to start, these are interesting sources of things that I could potentially find for ground truth. All right. Thanks a lot, guys. Thank you so much.